Code organization isn't so much about communicating with a computer, but rather making sure that as your code evolves, it can be understood and maintained by yourself as well as others. Most programming languages have specific measures in place to help you organize your code. And in this week, you learned all about Swift's best practices. More specifically, you learned how inheritance, protocols, and delegation enable you to maintain structure within your code base. Over time, and as you become more comfortable using Swift, the apps you create will grow in size and complexity. And when this happens, it's important to ensure your program's framework is solid and consistent. With that being said, let's reflect on the key concepts you learned about that will help you achieve just that. You started this week with an introduction to inheritance, where you learned that, like how children inherit traits from parents, a class can inherit traits from another class. This process is known as subclassing, the process where a child class inherits properties and methods from the parent. You then moved on to explore how you can use typecasting to check an instance type, and to cast an instance to a different type. You learned that there are two operators in Swift that assist in checking and ensuring an instance type. The typeCheck operator that checks whether an instance is of a certain subclass type, and the typecast operator that lets you downcast an instance. This means that you should now be able to differentiate between the is and as operators to type, check, and cast class instances. Next, you discovered that polymorphism describes the process of modifying the properties and methods inherited by a subclass. So this means that a subclass can take on a different form than the form passed down from the parent class. Like using one spaghetti dish as a base for another, where you add some extra ingredients. You explored how to alter the behavior of a base class method by applying method overrides that essentially change the functionality of the inherited method. Next, you explored how protocols allow you to create rules and set expectations using code. You learned that a protocol sets the required properties and methods that are needed for a specific task. Like a blueprint, a protocol doesn't execute the implementation of its design, but instead maps the overall property and method requirements that an instance needs to conform to. You explored the protocol syntax, where you learned how to make a protocol property requirement readable and writable using the getter and setter methods. You also studied how to configure a method requirement by only defining its parameters and return type. You learned that adopting a protocol means that the adoptee will have to conform to the protocol requirements unless the requirements are declared as optional. At this point, you practiced implementing protocols with classes and then moved on to learn how to implement required and optional methods. You learned that to indicate that a protocol method is optional, you use an @Objective-C attribute. Recall that an attribute provides information, and in this case, @Objective-C tells the compiler to make your code compatible with Objective-C and Swift code. You explored the optional protocol syntax and learned that each optional protocol requirement must be prefixed with the @Objective-C attribute as well as an optional modifier. You also discovered that optional protocols only work with classes and not with structs. This is because Objective-C doesn't have the concept of a structure. Following your learning on protocols, you moved on to explore how tasks can be passed from one instance to another. You also explored how the delegation coding pattern gives control and passes responsibilities to an instance, reducing the overall complexity of your code. So instead of having a single instance accounting for multiple jobs, you can spread the responsibilities among multiple instances to better organize your code. This is made possible through protocols that oversee the integration of the delegated tasks. By applying the code organization structures you covered this week, you'll be doing your future self a favor. Maintaining a solid and consistent structure throughout your projects will help ensure a streamlined workflow moving forward.